So when you open this, right, you have this command window. You can see this is command window. You have workspace over here, right, and you have an editor. This is an editor window, right? So this command window, this is a place where you actually run the program, or you run your whatever the codes you write. So in editor window, it's like you edit here. It's like a draft. You can do whatever you want. You just keep writing any kind of thing, and it will not run here until you give a run command here, right? In command window, if you type anything, it will keep on running. If you press enter, then it keeps on running in command window. So these are the basic stuff in MATLAB. So in workspace, it will save all the variables which you have defined. Okay, for example, right now I'm saving x is equal to 2, right? I pressed enter, so it ran it. I'm running it in a command window, so I got an output as x equal to 2. Then you can see in workspace you have a variable, it is saved here in workspace. Okay, so this is generally this is how the interface looks like in MATLAB. So right now I'm using 2020A. I think now 2022 is also available. So there's not much difference between all these versions. Like you can do most of the things. So let's start with a very basic ones. So right, I'm just giving a small thing. It is let's say 2 plus 3. So whenever I press 2 plus 3 without giving any term on the left hand side, it saves as answer. Like you have this ans is equal to 5, answer is equal to 5. So same thing you can see in workspace. You have variable saved as answer, and the value of the variable is 5. For example, if you save it as, let us say I'm writing it as x is equal to 2 plus 5, then I'm defining my variable. So now you can see here my x is equal to 7, and the variable x is saved, and the value is 7. Okay, so like what the calculator does, you can do all these things. 3 square is 9. Similarly, 3 multiplied by 3 again is 9, something like that. So 4 divided by 2. These are very basic operations in MATLAB, right? For example, you have 4 divided by 0, you get INFX infinity. That's what there are some defined definitions here, so you can go through this. INF is infinity. Sometimes you may get NaN also. NaN, it's not a number, something like that. Okay, then so if you want to clear the window, you just press CLC, so the window will be cleared. If you want to clear all the variables which I have stored before, so these are the variables, right? So if you want to clear them, you just press clear all. So everything is fresh now. You can start it fresh. You can start everything in a you can start everything new here. So any doubt so far? Okay, thank you. So let us start something. For example, if you have something called, so MATLAB is basically, it works on MATLAB. It works on matrix, right? Matrix operations. So any mathematical statement, you can actually convert it into matrix notations, and you can solve those problems. And advanced structure mechanics, right? In advanced structure mechanics, or in any structure mechanics, or in our civil engineering, most of the problems can be you can break them down into the matrix operations. You can just formulate a matrix, and then you can use that, and you can actually get the solution from them, the matrix operations. So we have, if for example, let us say we have a stiffness matrix or some matrix as A. Now I'm starting, I'll show you how we define a matrix. So square bracket open, 1 space 2 semicolon space 5 space 9. So how does it actually shade, like how the MATLAB saves this? You can see 1 space 2 is like 1 2, and then next row 5 9. So you can see now, so 1 2 5 9, that is how it has saved it, right? So for example, the same thing I have, a is equal to 1 2 5 9. Now I press semicolon here, so you can see the difference. So now you didn't get this output, you didn't get this, this is not displayed a equal to 1 2 5 9 here, because it automatically saves in the workspace, but it is not shown. That is, I mean, the display is compressed over here. Fine. So that is how the semicolon works. So if you want your results to be shown after you run a program, you just remove this semicolon, your results will be displayed here. But if you want to just store the results, you just enter this semicolon here. Okay. And coming to matrix, various matrix operations, right? So you have, let us say you have a transpose of a matrix. Transpose, I'm just defining a transpose is equal to a. In MATLAB you just need to press a dash, a prime, right? So you get transpose. This is how the transpose is, right? 1 2 5 5 9. And if you want inverse of the matrix, inverse, you have this inv of a. So whenever, see, if you just want to check whether your syntax is correct or not, once you press inv and just press this, open this bracket, it shows inv of x. So I need inverse of a, so I'll get, this is inverse of a inverse, right? So all this see what this syntax, because I was using it since a long time, so I know how what are the syntax. For if you just want to know this, you can directly search in this there is this website called MathWorks. So you can just go into this website and you can search whatever syntax you want. For example, inverse of, let us say I need inverse of matrix in MATLAB, right? So you just go to this, you search it, you will find all the syntax here. Okay, see, y is equal to inverse of x, so you will get inverse of x, and you have a lot of examples also. So this is about matrix operation. So you have one more thing. For example, I am defining B matrix now. Okay, B, I have 1 6 1 1 0. This is the code of your, I think this is your the course code, I think. Yeah, 6110. So let us say B is equal to 6 1 and then 1 0, right? So yeah, now I want matrix multiplication. So like I said, it is just A star B. So this is matrix multiplication. This is A multiplied by B. Now I need dot product, right? So what is dot product? Each element is multiplied to the corresponding element in other matrix, right? So if I want a dot product, then C is equal to, now yeah, okay, A dot star, right, dot star B. So if you see, 1 multiplied by 6 is 6, 5 multiplied by, where is it, yeah, 1 is 2, sorry, 5 multiplied by 1 is 2, sorry, 5 multiplied by 1, sorry, where is it, A star B, yeah, where is A, sorry, 1 multiplied by 6 is 6, 2 multiplied by 1 is 2, 5 multiplied by 1 is 5, 9 multiplied by 0 is 0, right? So I'm just clearing my window. So similarly, you can use this for your whatever other operations also, right? Like if you want to multiply, if you want to take a dot product, you can use that, and if you want a normal multiplication, you can directly use that that star option, whatever, A star B. Next, what I want to show you is, yeah, for example, if you want, let us say I'm defining x is equal to 0. Now here this is column, okay, 0 colon 0.5 colon 4. So let us see what it does. Yeah. So colon is actually it gives you a space, right? It creates a space. Now x is starting from 0 and it ends with 4. It is spaced at regular intervals of 0.5. That is what it means. If you see here, let us see how x is stored here. I'm double clicking on it. So you can see here 0, 0 0.5, 1, 1.5, 2, 2.5, 3, 3.54. Got it? So that is how it is defined as 0 colon 0.5 colon 4. This is the colon operator. Then yeah, any doubts so far? Okay, thank you. So next, yeah, for actually you have assignment on Gauss-Seidel, right? Gauss-Seidel iterations. Yeah. So for Gauss-Seidel, you may be required to use for loops, sometimes maybe if loop also, right? So yeah, before that I just want to tell you one more thing. Okay, let me, what is A? Like, I'll just type A, so I got this A matrix, right? So for example, if you want to print some results, right? From, let us say I want to print. Before that, let me show this how this round brackets work. So A of 1 comma 1, what does it give you? So 1 comma 1, see, if you are expressing this in this fashion, 1 comma 1 is actually the the address of this element, first row first column element. So it should give me 1 as answer. Yes, that's right. So then A of 2 comma 1, that should give me 5. So this is how this A of works. Okay, and then if you want to print some values, print this is the syntax, f print f. Okay, f print f of, I just want to write some value like first row and second column of A matrix is okay. So I just want to print first row and second column of A is something like that. So here I need to enter first row and second column. If you see here, yeah, so this is how it is printed. First row and second column of matrix A is 2. That's what it is. It is 2. Right. So this is how fprintf works. So fprintf, again, you need to take care of these codes, right? So whatever you write in this code, it prints as it is. So this percentage d is actually the value which it gives us. So value is defined after this comma. You place a comma, then A of 1 comma 2. This is what is stored here. This percentage d, and this slash n is nothing but it. Once it prints, right, you go to the next line. That's it. That is what it's backslash n means. So this is about printing. Okay, and then yeah, now let us see how this for loop works, right? So again I have let me just print matrix A. So first I'll just write this code, a small one. I'll explain everything in detail. So
Matthew, are you not able to record it?
Actually, sir, I'm not I'm recording it in presentation, sir, PPT, because I don't have that option here, so I'm recording it.
If you want, I can switch on the recording, but I'm worried that you might have missed. I just joined actually,
No, sir. Actually, I started recording it already. It
so
is, yeah,
not required, right?
yeah, not required. Not
Okay, thanks.
okay, sir. Yeah,
Okay, you carry on. I'll leave now.
sure, sir. Thank you. Okay, see, right now I'm running this for loop, right? So in this, okay, now here, if you check, I have called A matrix. I have A matrix. A is 1 2 5 9. B is, if you check here, B is equal to zeros 2 comma 2. So what does it do is, what does it save as is 2 comma 2 by 2 matrix, that is 2 rows 2 columns matrix with zeros as its elements, right? So initially I am giving B, I am defining B as all zeros 2 by 2, so that is what it's printed here. You can see 0 0 0 0. Now now what I'm actually planning is, I want B matrix to be equal to A matrix. You can directly do that by just saying B is equal to A, then you'll get B, but that is not the point. So I just want I just want you to understand how the for loop works. So if you check here, for I is equal to, I am again defining some other variable called I. For I is equal to 1 to 2, and for j is equal to 1 to 2, b of I comma j is equal to a of I comma j, right? So how for loop works, right? So let me show you here. Again, as I said, this is editor window. If you press enter, you can edit whatever you want here. Unless you run it, it will not run. Unless you press run button over here. However, if you want to press run over here, you need to save this file. Only then it runs. So unless you run it, it will not do anything. So you can actually check here. So for j is equal to 1 to 2, and then b of I comma j is equal to a of I comma j, right? And then so yeah, this is ending code, right? So if you see in this, what's happening, yeah, I also have A matrix. A is already defined. I have some A matrix. So A is defined. And what is A? 1 2 5 and 9. Okay, so we'll just see how this is working. So for I equal to 1 to 2, that means I is starting from 1 and it goes to 2. That is for I is equal to 1 comma 2. If you remember, previously I showed x is going from 0, x is equal to 0 0.5 to 4, right? So that means it's starting from 0 and ending at 4 with an regular intervals of 0.5. So here there is no in between term, right? That means it is an integer. So it starts from 1 and it goes and it goes to subsequent next integer, that 1 2 3. For example, if I have 1 to 4, then it starts from 1 2 3 4. So for I is equal to 1 to 2, and then again for j is equal to 1 to 2, b of I comma j is equal to a of I comma j, end. So what happens is that initially I is stored as 1. So first thing here, I is equal to 1, and then again j is equal to 1. So 1 which is carried from I, and j it runs from 1 and 2. So b of, for the first loop, b of 1 comma 1 is equal to a of, again I is 1 and j is 1, a of 1 comma 1. So if you see here, b, this first result, whatever the result which we obtain, this is nothing but the first loop. B of 1 comma 1 is equal to a of 1 comma 1. A of 1 comma 1 is 1, so that's why it has stored 1 0 0 0. the rest will be again the same. Next it will again go into the loop, right? Because we also have j is equal to 2, so we have I equal to 1 and j is equal to 2. B of 1 comma 2 is equal to a of 1 comma 2. So you can, if you see the next loop, it is 1, I mean 1 comma 2, right? So this is already saved, it is already there, because from here it has taken those values. And then b of 1 comma 2 is nothing but a of 1, b of 1 comma 2 is nothing but a of 1 comma 2. The same thing is repeated. Then it is completed, right? It is ended because j has completed its journey from 1 to 2. Again it will go to the outer loop. What is outer loop? For I is equal to 2, then I we have done with 1, so now I is equal to 2. Then j runs from 1 and 2 again, and that's how these values are formed. So b is equal to 1 2 5 6, I mean 5 1 2 5 9, which is nothing but it's a. So that is how the for loop. You need to write these encodes. Encodes are must, only then it keeps ending, if not it keeps running. So any doubts in this? Okay, thank you. And you have one more, maybe you also require this if loop, how if works, right? So I'll also show that. Let me write nr. I'm just making this nr is equal to 3 nc. Nr is nothing but some, I'm defining some variable. Nc is equal to 3, a is equal to ones. Right now I'm actually defining ones, not zeros like previously. And for c is equal to 1 to nc. For r is equal to 1 to nr. If r is equal to c, a of r comma c is equal to 6. Else if absolute value of r minus c is equal to 1, a of r comma c is equal to minus 1. Okay, then else a of r comma c is equal to 0, and again. So previously I forgot to tell you one thing. So right there I did not mention, I mean after this statement, right, I did not use semicolon there. So if I have used semicolon, right, I would have directly got this answer. Because see, if I, because I didn't use semicolon, it is giving me, it is printing me this b value for every loop it is running. So here the loops are like two. I is running from 1 to 2 and j is running from 1 to 2, right? Like if tomorrow if you are writing the same program for Gauss Seidel, right, you it I think it runs for many, like thousands of loops. So there if you see that, right, all these thousands, whatever the loops it has run, you'll get this printed, you'll get each loop answers. So that is not necessary. So you just try to use semicolon there, so that you will directly get the end result. So we actually need only this result, right? B is equal to 1259. B is actually equal to A. That's what we need. So here also again for explanation purpose, I'm not using any semicolon. Let me just check. Let me just show you this. So yeah, so I just wrote this code. I'll run here. Let me. So I'm clearing it. I'm clearing all my variables, my previous variables, and also clearing the screen. So let me check. Yeah. So again, what's happening here? If you see here, I have again I have my number of rows. I given nr as a variable. Nr is equal to 3. Number of columns as 3. Now a, initially I am defining a is equal to ones. Okay, ones nr comma nc. That means ones 3 by 3 matrix. here as I mentioned like I have entered semicolon here, that's why my initial a value is not printed here. If not, I would have got a is equal to 1 1 1, all ones. So again I'm starting a for loop. If you see here, for C starting from 1 to NC, that means C going from 1 to NC is 3 1 2 3. So now I have C values going from 1 to 3, so 3 values. And again R starting from 1 to again 3. If R equal to C, that, see, this is actually a conditional, this is logical statement. That means if R equal to C, that means it's true, 0 or 1 kind of thing. So if it is true, then a of R comma C is 6. That means uh, yeah, again a of R comma R is, what is R? 1, C 1. So a of 1 comma 1 is equal to 6. When is it? When R is equal to 3 C, I mean when 1 equal to C. So in this sense a of 1 comma 1 should be 6, because again R is equal to C, that is true. So if you see here, that is what it is printed here. Sorry. Else absolute value of R comma C, ABS is absolute value of R comma C is equal to 1, then a of R comma C is equal to -1. Okay, again else, that means if both these statements are not satisfied, then whatever all the others thing, whatever the others comes into the picture, so that will be satisfied. So for that a of R comma C is 0. So I'll go through 2 or 3 loops, you can understand. So first loop we already got this. Second loop, again, what is the second loop? R is equal to 2 with C equal to 1. That means sorry, so R is equal to 2 and C equal to 1. Absolute value of R minus C is 1, so this is true. That means this should be satisfied. So a of 2 comma 1, what is it? Yeah, this. So we have printed a, that is equal to -1. So what is the other one? Next loop, R is equal to 3. So for R equal to 3, then this is not satisfied, this is not satisfied, so this is satisfied, right? So a of 3 comma 1 is 0, that is what here, a of 3 comma 1 is 0. Likewise you can do it for all the other loops, you can just check it, that will be satisfied, and this is my end result. So this is all about if and for loops.